Right guys, so this last example for today, it says, show that the equation given, x cubed minus 5x plus 7 equals 0, it can be rearranged to form the following iterative formulae. So the xn's and the xn plus 1s, they make it look complicated, but essentially what you're doing is you are going to isolate or make one of these x's the subject, either that one or that one. Okay, and having a look at this one, it looks like I've still got an x cubed in my rearrangement, which means they've probably isolated that one. Okay, so I'm going to keep everything here apart from the minus 5x. I'll put that on the other side. So here I can see I'll have x cubed plus 7 is 5x. And then I'm going to divide by 5. Okay, so I'm going to write x cubed plus 7. And rather than writing divide by 5, I'm just going to put 1/5 in front. And that equals x. And then you can see this is the same as that there. Okay, they've got these n plus 1s. And that's xn, all right? But it means the same thing. So they're saying that you can get to the next term by using the previous term and this relationship. Okay, and you do exactly the same for this one. Now in this one, I need to get from there to there. And again, I've got to isolate one of these x's. Okay, and it looks like I have a cube root in my answer. So I'm thinking it's that one I'm isolating. So here, I'm going to rearrange that. So I'll start with writing this bit here on that side. So that'll be positive 5x, negative 7. And then I'm going to cube root. Like that. And then to make it look like this, that's just the next term. This is the previous term. Okay, done. That's it. All right. The next bit, it says using x1 equals minus 2 in each case, find the values of x2 and x3. And then it says show on separate diagrams whether or not convergence takes place. Okay, so I'm going to start with x1. Okay, so x1 is minus 2. And I'm going to sub that minus 2 into there to get x2. So I'm going to write 1/5 minus 2 cubed plus 7. I just want to advise you, I always tend to put brackets around any negative values because calculators can't always cope with negative numbers and powers. So I'm just going to type that in. So that's 1/5. What is it? Brackets. Another bracket for minus 2, power 3, and then I'm going to add 7. Close the bracket. There we go. So that gives me minus 1/5, which in decimal form is minus 0.2. I'll just stick it on. And then to get x3, I'm just going to overwrite the minus 2 with answer. There we go. There's x3. I'm just going to squeeze it on. 1.3984. What else does it want me to do? Okay. And then it says show on separate diagrams whether or not convergence takes place. I'm just going to do a quick check. So I'm just going to keep pressing equals and see what happens. So if I keep pressing equals. All right. That got big pretty quickly. Okay. So you can see that this is not converging. This is diverging. It's going off to a massive number. All right. And if I press equals again, there we go. All right. Massive. So this is probably diverging. I'm just going to write diverging. Okay. I'm cheating a little bit because I use my calculator, but I'll show you in the diagrams as well. On the other one, I am going to do exactly the same. So if you work out x2, cube root of 5 times minus 2 plus 7. Again, I'm going to use my calculator, type it in, cube root, 5 brackets minus 2 plus 7, like that. Give me minus 1.44, press equals, that gives me x3, minus 1.44 again, and again I'm going to do a little bit of cheating, and no harm in that. Keep going. Pressed equals a number of times. It looks like this is converging, okay? Converges. Because can you see it doesn't change much. In fact, it's not changing at all, okay? It's probably because the calculator can't cope with it. But it looks like it's converged to this value here, okay? And then it says, show on separate diagrams whether or not convergence takes place. Now, you guys have your diagrams missing, so you might want to pause the video and get the diagrams down first before you continue. Okay, so you might want to press pause now and then come back to me once you've got these two diagrams copied. There they are. Okay, coming back. Right, so it said starting at x1 equals 2. Now, it's missing on your diagram, but x1 equals 2 is about, it's about there. X1 equals 2, minus 2, sorry, there's minus 2. And do you remember I said you always go to y equals x second? Now this here is actually the curve of 1/5 x cubed plus 7. So this is y equal to 1/5 x cubed plus 7. So where these two intersect, there, that would correspond to the root of that quadratic, because it's just us rearranging it. Okay, so if I try and do the convergence, so here it is, I go to the curve first. It's not easy because it's pretty straight, and then I'm going to go to the line y equals x, like that, and then I'm going to go up to the curve. You can draw a dotted line if you want, like that, and that would be my x2 there. That's x2. All right, and then I'm going to repeat the process. I'm going to go to the line like that, and then I'm going to go up to the curve, and that there is x3, and then I'm going to go again like that. And you can see why your x values get really big really quickly, because you're ending up somewhere here, and that's your x4. And if you repeated the process, you would go off to a massive number there, and you can see quite clearly it diverges. Okay, on this one, there's y equals x, and this curve here represents the cube root of 5x minus 7. So here I'm just going to label that y equals the cube root of 5x minus 7. And where these two intersect, yeah, that would correspond to the root of the original quadratic. Okay, so again, we're starting at minus 2, which would be on this diagram about there. I think I'm just going to, I don't know whether that's right actually. Is that minus 2? Because that doesn't look like minus 1.44. What am I doing wrong? 1, 2, 3, 4, 5, 6. If I made a mistake there, I'm just going to go back and check. I don't think I have. I'll come back to it in a second. I don't think I'm wrong. This here is x1, which is minus 2. And I go to the curve first. Okay, you always go to the line second. And then if I go across, it looks pretty straight, but actually it's because my diagram's a bit dodgy. But actually this is more of a curve like that. And then if I go across and then back down, you can see that this here is x2. And then you go across again, you go down, and that's x3, and so on. And you can see that it's getting closer and closer to where they intersect. So this one converges and that one diverges. Now they won't ask you why in the exam. I can tell you why. It's to do with the gradient at where it intersects. So can you see that the line y equals x, that is less steep than the curve itself? Okay, if the line y equals x is less steep than the curve, then it will converge. Now you can see quite clearly this part here is much steeper than y equals x. On this one, the curve is not as steep as y equals x. And technically it could be the other way around, so you could have a gradient like that, but as long as your gradient at that point is not as steep as this line, it would converge. I'm just going to go back and check if that's wrong, and if it is, I'll email you about it.